Do you guys remember what it means to solve a system of linear equations? What do you normally do if you have one equation? Usually try to get the variable all by itself. Okay? How many variables do we have on each one of these equations in number one? Two different ones. Okay, so you normally will have at least two equations if you have two different variables to solve. So if you're looking for a solution for a system of equations, which means two or more equations with multiple variables, it means you need to find the x and the y that works for both equations. Okay, there's specifically a number that I can plug in for x and a number for y that will work for the first equation, and it will also work for the second equation. Okay? If we can't find a combination that works, there's no solution. And we've had that before where there was no solution, where we get something like 10 equals 5, which is not true. Okay? But if that happens, there's no solution, there's no like combination of numbers that will work for both. If we run into the case where I get 10 equals 10, what would that mean? What did it mean with one equation? 10 equals 10. I would say if that's true or false. Would that be true? Or would that be false? It'd be true. So then that means it actually, there's a like an infinite number of x's and y's that work. Okay. Between 1 through 6, maybe we'll do 2 or 3 of these problems. Are there ones that you guys would like to see in particular? Does any of them look harder than the others, and you'd rather do the harder ones together, or do you want to do the easier ones here, and then you guys do the harder ones by yourself? Okay, well, you have a pick between 1 through 6 if you don't care. 6. Okay, let's do 6 then together. There's a couple of ways that we've covered in this chapter, or this unit, for solving equations. There's substitution and there's elimination. Let me write the problem up here again. Actually, negative 3x plus 5y plus 15, and 9x minus 15y is equal to negative 45. For this one, I might try to do elimination. Okay. Basically, what you're trying to do for elimination is you're trying to get these. Neither of these look the same, right? I've got a negative 3x and I've got a 9. They're completely different numbers. Okay. I would like to get the opposite number. Okay. What do you guys think would be the opposite number of 100z? Negative 100z. Good. So I don't have an opposite here. Sometimes I already have the opposite and it's super easy. But if I was trying to get the opposite of 9x, what would I like this one here to be instead? Not 3. 3x would be the opposite of negative 3x, but if I want, usually I would try to take the bigger one. If I want the opposite of that one, it would be negative 9x. Okay? Well, what would I have to change if I did have a 9x right here? Let me push this down a little bit. If I did have a 9x there, what would I have to do to the 3x to get it to 9x? What would I have to multiply it by? 3. Yeah, positive 3. So you don't have to do this like thing here. There's different notations that we could use. Okay, but so I want to take this whole equation and then multiply it by 3 and then write everything that would result. Okay, well, I also, so if I took 3 times negative 3x, I would get, oh, sorry, we should have a negative 9x there. Sorry about that. I also would have to do 3 times 5y. What would that be? 15y. 15y. Positive 15y. And then 3 times 15, you guys know what that one is? Is that yours? 3 times 15 is what? 45. 45. You guys are allowed to use calculators, but I'll be thinking 15. 15 plus 15 is 30. 30 plus 15 is 45, which shouldn't be too hard to think about. The bottom equation, I don't actually need to change at all, so I'm going to leave it exactly the same. If I want to use some notation, then I might just say distribute a positive 1. Okay? So I have a 9x, a negative 15y, and then a negative 45. Okay? Okay, there's a reason why we multiplied the top equation. Okay? Because we're gonna do like this funky looking addition problem. You guys remember when we would add like two-digit numbers? We would kind of stack them on top of each other and then just add straight up and down. I'm gonna do something similar over here. All right, so remember that this is a negative 9x. What is negative 9x? And this one here would be a positive 9x. If I add those two together, I actually get 0, right? Don't they cancel out? Okay. Typically when we're doing elimination, at least one of the variables will cancel out, okay? This one seems to be like a funky example where we have more than just one variable cancel out, right? What is 15y and negative 15y equal? 0. Okay, so this one actually cancels out. Normally I wouldn't have to write 0, but since there's nothing left on the left side, I kind of have to put a 0. I can't just leave a blank space. All right, and then 45 and then a negative 45. That will also equal 0. Okay, so actually everything cancels out. What did we say when we get down to just numbers? We just determine if it's true or false. Would this be a true case or a false case? Gloria, does 0 equal 0? Yeah, so I would say it's true. What did we say if it's, what does true imply? How many solutions? Infinite. So there are infinite number of solutions. We're going to have some problems, I believe, if I recall right, on the test. We're going to have some problems where you see pictures of graphs, and you have to determine whether it's one solution, no solution, or an infinite number of solutions. What this would look like, on a graph would be if this one right here was the purple line. If I graph the purple line, say it was like right there. Okay, a solution would be wherever they cross. Okay, so if I had one that went like this, that would be my one solution. This ordered pair, this x comma y, that would be the only pair that works. But actually, in the event of an infinite number of solutions, I actually have the same line that overlaps. So they're really the same line. Trying to think of an example. It'd be kind of like, I've never run a marathon. Has anybody ever run a marathon before? Or have family members that have run marathons or like long races? What's that? Not the running type. I've got a cousin that, have you heard of those like Spartan races? They're like marathons with like all these random obstacles and stuff. He and his fiance are super into that, and they always like post their pictures with their like little medals and stuff. But like if you have 1,000 people or a few thousand people running a race, you can't have them all run at the same time, right? So they kind of break it up. So sometimes they have like the girls go first, and then maybe a few hours later they might have the guys go first, or maybe they break it up into chunks where they have like the first 100 people go, and then wait 20 minutes, and then the next 100 people go. That way it's not too cluttered, all right? But you could have someone start at like 11 a.m. and then they would finish 2 hours later, so that would be like at 1 p.m. And then maybe someone starts at 12, but also take 2 hours and finish at 2 p.m. So maybe the times would be different, but the length and the speed is probably exactly the same. Okay. Okay, so that's number 6. So number 6 would be true, infinite number of solutions. Let's check out a different one. don't know that these are all the best examples because a lot of them seem to give you either true or false, and ideally we would see some that are a mixture. Let me erase some of this. Let's do one more. Is there one more that you guys would like to see, or let me think if there's one that's in particular that looks good to you. Let me pull an example up real quick. Okay, while I'm doing that one, go ahead and try to fill in some of the other 6, okay, because you're going to have to do them anyways to turn in. I'm going to pull up a different example. It looks like I picked a bunch of examples that give you either true or false, okay, and I want to give you an example where you get one solution.
She looks big mad. I am big mad. Not you, Pepe. Hey, there's a class going on, so I don't know why you are talking across the room when you come in here with this attitude disturbing the whole class. I didn't even say anything when I walked in here. Yes, you did. You're talking over here. Made a big deal as you walked over here. Yeah, I just said something now. I did because I thought he was talking to me. No, you didn't. You were talking about his company. Someone else. Okay. I got it.
Okay, here's a different example, guys, to give us a little bit different practice. Okay, not too tough though. If I'm looking at both equations and I like how my x's are lined up, my y's are lined up, and then my constants are lined up, okay? Are any of them already opposites of each other though? Are any of them, so there are none that are already perfect opposites. Are there any ones that are actually close to being opposites? And I'm looking specifically at my x's and my y's because my constants don't help me out too much. Which one is the closest to already being an opposite? The y's. Okay, so that would be the easiest route to go, is to say, okay, I have a positive y on the top, I have a positive y on the bottom. I would like if one of them was actually negative. So we could pick. And if you decided to work with the x's first, that's fine. It just would be a different set of steps to get to the same answer. So let's do one here. Would you guys rather make the top y negative or the bottom y negative? Because we just need one of them to be the opposite. What do you guys pick? Charlotte. You guys can't say top or bottom? You just can't. Top. Okay. All right. If I want the top one to be negative, then I do know that I want to have a negative y over here. Okay. What would I have to multiply this equation by to get the y to be negative y? Just actually a negative 1. Okay. Do you guys agree? Like if I'm going to distribute these, when I did this second one, negative 1 times positive y would give me a negative y. What would my x end up being instead?
Negative 1x.
Just, yeah, negative 1x. You can put the 1 there if you like. And then the one thing that students forget a lot of times when they do these problems is they forget to do the 1 on the other side of the equal sign. And I don't want to forget that this will be negative 6. All right. Now, let me go ahead and copy the bottom problem. If I was to think about it being distributed to something, it's just positive 1. It stays exactly the same. So this would be a negative 3x plus y equal to 2 should be exactly the same if I'm multiplying everything by 1. Okay? Now I can make my kind of like funky addition equation where I make this long equal bar and I'm just going to combine everything straight down. Oops, getting too close to the date. Okay, what's negative x and negative 3x combined?
Negative 4x.
Yeah, negative 4x. Okay, my negative y, my positive y, that should cancel out. That's exactly why we chose negative y. And then negative 6 plus 2 is going to give us negative 4. Now I get to an equation that looks a lot easier than the, well, whatever 2 we started with. I just need to solve for x at this point. And this, some of you guys might have been doing since almost 5th grade, or 6th grade, 7th grade, depending on where your teacher might have introduced it. What would be the first step here? What do you guys say? Daniel or Daniel? What would I do? What variable am I trying to get by itself at this point? The x. Okay. What do I do then? Divide by, I could divide by 4. I'd rather divide by negative 4 so I can take care of the negative sign too at the same time. Okay. These cancel. Negative 4 divided by negative 4 is going to be a positive number, and it's going to be positive 1. Okay, so I know that x equals 1. That's only halfway there, though, because what else do I have to figure out?
What?
We have to figure out y, right? So all I do is take either one of those equations. Let's say I take, let me highlight this for a second. Let's say I just use this one right here, and I'm going to rewrite it down below. Say, okay, x plus y equals 6, but now I know that x is equal to 1, so I'm going to plug that in. Okay, I'm going to say, okay, this is actually equal to 1 plus y equals 6. Right, these are some of the first algebra type of problems you see when you're solving for equation, whether you just have to add or subtract. All I would have to do here is, in this case, get rid of the 1. So I would subtract 1 and subtract 1 from both sides. I know some of you guys like to do like some type of dotted line or dashed line or straight line. These are gone. 6 minus 1 is equal to 5. So now I have the x. Now I have the y. To get full credit, I just need to say my answer in a particular way. So especially when you guys are doing those like state testing, or if you guys are going to take like the SATs or the PSATs or the ACTs, I don't know which tests you might be taking in a few years. I have to write it in an ordered pair. Okay? How would I write these answers combined into an ordered pair?
1, 5.
1, 5, perfectly. That's your final answer. So don't miss this like one extra point, because if you already found your x and you already found your y, you did all of the hard work. All right, we just need to write it as our final answer. Okay. Let me try to find, let me get one more example to do like this. Let's see. So we don't want to get too tight. Try to find one that is a little bit tougher, just so we have the practice, but I think I'll get that in a moment. Good. Let's try this one. I try this one on your own, and we'll go over it in a minute. This is a little bit tougher than the last one we did. Okay. When you see a problem like this, you first check to see, do I have an opposite already? Okay, sometimes you already have an opposite, and if you did, you would just go, oh, let me add right away. But we don't have an opposite right now, so I need to make two new equations, or maybe just change one of them. Sometimes we have to change one, sometimes we actually have to change them both a little bit. Okay, and I'll give you the next example we'll have to change both. Try this one on your own, we'll come together on a class on that one. Yeah, you might want to do it on the back. You guys have an option too. So some of you guys might try to get rid of the x's. Some of you guys might try to get rid of the y's. Did you get it? Did you copy it down? Put on the back there, because it's not. Which one are you trying to make the opposites of? Okay, so you will need a negative sign, so I'll give you that. But if you multiply it by negative 1, it's going to be negative x. Over here, it's going to be 4x. But they're not going to be opposites of each other. What do you need this one to actually say over here? So instead of multiplying by negative 1, it should be negative 4. So then that changes the other two as well. Okay? Did you get it or no, bud?
Oh, yeah, it's in.
Are you gonna write it down? Oh, okay. I'm gonna just get the next problem ready. So. If you guys feel like good on that one before we get to it, you can try to do this one here. Oops. Got a few bigger numbers. Okay. Let's go back to this one though, so we can get to some of the other problems as well. I don't have any opposites right away. Okay, which ones would you guys like to just get rid of first then? The x's or the y's? And it doesn't really matter. Maybe one way would be slightly easier, but not necessarily. For one person, it might be easier the other way. Which one would you guys like to get rid of, the x's or the y's? The x. Okay, so if I wanted to get rid of the x, do I need to change both equations, or do I only have to change one here?
One.
You would only have to change one. Probably the bottom one. What would I need to multiply this? What is the opposite of 4x, by the way? Negative 4x. So I actually want over here to say negative 4x. What would I need to multiply that x by? Negative 4. Okay, so the top equation is exactly the same. What's going to follow the negative 4x?
Plus 4y.
Plus 4y, good. And then, I don't know how you guys' 13 times tables are, or how well we can count by 13s. It would be negative 52, good. All right, now I'm going to do that like giant weird addition problem. I know that we decided that we were going to cancel out the x's, so those are gone. Then I have 2y, a positive 2y, and a positive 4y. When I combine those two together, it gives me a positive 6y. And then a positive 10. Negative 42. Okay, now I got down to just one variable, and that's a lot easier for us to solve. At this point, divide everything by 6. This will be negative. What is negative 42 divided by 6? Negative 7. Okay? All right, so I found what y is. Am I done? No, I really did the first step. The first step is the toughest step. Now I go to the second step, which isn't too bad, but I'm going to take one of either the top equation or the bottom equation. Sometimes one equation will look a lot easier to use, and it might be easier to use than the other, but if you plug it into the top or the bottom, it doesn't matter. Is there one that looks like it might be a little bit easier? Or do they look equally easy, equally hard? Which one would you guys like to use? The first one or the second one? Second one. Okay, yeah, I would maybe pick the second one too. So I'm going to put a x minus, and then instead of putting the y, I'm going to plug in a negative 7. Okay, so remember, we're just rewriting the second equation, except now that I know what y is equal to, I'm going to plug in the negative y value, which is negative 7. All right, I should know that a negative negative gives me one positive. And this problem would still be pretty easy. All I'm going to do is subtract both sides by 7 and get x is equal to 6. Okay? All right, I at least see one of you guys already telling me what, or writing down the third step. What's the third and final, but also the easiest step? Come on, you guys did all the work. But you have to tell me your answer, but in a particular way. How would you tell me that?
6, negative 7.
6, negative 7, but in an ordered pair, right?
Yeah.
So a few things. I want to write it like this. Put a comma. And then, I don't know why a lot of times students forget the parentheses for some reason. Okay. Guys, make sure your phones are put away. We're not texting. We're not listening to music, so we can take those out. Okay. All right. Questions about this one? You guys want to try? We'll do one more, and it'll be even a little bit more challenging because we're going to have to change 2 equations. This one right here. Okay, so copy it down. I'll give you guys a minute to think about it and try to start working on it. You might get numbers are a little bit bigger because I see a 33 and a 36. So when I multiply one of those, it's going to be a little bit bigger number. But I allow you to use calculators anyway, so you can check your work. I know a lot of math teachers don't let you use calculators at all. Okay. First check is, do I have opposites already? No, I don't. Okay. Which ones would you guys like to make opposites of? Do you guys see one that would actually be even easier? Either the C's or the U's. I'm going to do this problem two different ways, okay? One way would be slightly easier, and the second way, just because sometimes you have to do it the harder way, okay? The first way, I only have to change one equation, okay, which is normally preferred, okay? The second way, I would have to change both. All right, so I'm going to rewrite this here. 6c plus 3u equals 36. Okay, now looking at this one, would be the easier way where I only have to change one equation. Okay, sometimes you don't have that option, but here I actually do. There's one that is very close to only have to changing it one of the equations. Okay, of the two, which between the u's and the c's, there's one that I would only have to multiply either one of the c's or one of the u's by one number. And usually you're looking at the smaller number and seeing what you can multiply it to get it up to the bigger number. I do know that it's going to have to be by a negative number though, because this one's positive, but also this one's positive and that one's positive. So I know there's going to be a negative involved. Any idea? What's the common factor between 3 and 6 and between 4 and 3? What's the least common multiple between 3 and 6? Do you guys remember what least common multiple is? So for example, the least common multiple between 2 and 4 would be 4, right? Because I could go 4 and then it would go to 8. But if I do 2 and I go 2 more, I'm at 4, and then they have something in common. Right? So if I go 3, if I kept adding by 3s, what would be the next thing that came after 3? 6. So let me do that down here. So 3, 6. If I'm looking at 6, well, I already have 6. These are already in common. So all I had to do was multiply this by 2 to get down to 6. Okay, and then we'll talk about the 3 and the 4 as well, because that would be the tougher one. But if I'm counting by 3s, I would get a 3, 6, there's a 9, and 12. And I know I would be stopping at 12 because if I count by 4s, what comes after 4, the next 2? 4 plus 4,
6 or 8.
8, yeah. Worried me for a second on the test. And then 12. So they actually also, you would have to find what the common number would be. In this case, so this would be the harder route, is if I try to get rid of the u's. Because I would have to multiply this one by like a combination of either positive 4 or negative 4. And this one a combination of 3. This one here, all I have to do is multiply this one by a 2 because I already get to a 6 just to start. So the easier route is to try to get a negative 6c right there. What would I have to multiply this one by? A negative 2. All right, so if I distribute negative 2 there, I get the negative 6c. If I distribute a negative 2 to the 4u, I get a negative 8u. Do you guys know what negative 2 times 33 would be? Negative 66. Good. Okay, the bottom equation is already ready to go. Okay, so I didn't have to multiply that by anything. Okay, now I do like my weird adding. Since we decided to get our C's opposites of each other, Those will cancel. Negative 8u plus 3u is going to be a negative 5u. What's negative 66 plus 36? It's a negative 30 though. And then from there, it should be like almost automatic. Divide both sides by negative 5, and then you get u is equal to 6. Okay? Once I have u is equal to 6, what would I do? I have to figure out my c. How could I figure out c? How did we do it in the last problems? We put it here. Going back here, we found the y was equal to negative 7. What did we do with that information?
You put it in for
Yeah, we put it in for one of the equations for the y. So if I was going to go back down here, let me zoom up a little bit more just so I can see it easier. I would say, okay, I know u is equal to 6. I can pick either the top equation or the bottom equation. Let's just pick the top equation. 3c plus 4 times 6 is equal to 33. And then I would just solve for c now. All right. Hopefully we know 4 times 6 is 24. 3c, I would subtract 24 from both sides. And get 9. And then if I divide both sides by 3, I get, oops, I forgot to switch back. I get c is equal to 3. So then I know my u, I know my c. Do you guys know which one would come first in an ordered pair? If you had to write it in an ordered pair? Would I put the c first or would I put the u first? Or does it matter? I would maybe put the 3 and then the 6, because alphabetically speaking, the c comes before the u. They don't give you any like indication. I wouldn't ask you for an ordered pair though if it were different letters besides x and y. Okay. All right, let me show you the tougher way, but we could have done it that way. Okay, and I'll just do it straight over here on the right. If I wanted to get rid of the u's, what did we say their least common multiple was between 3 and 4? Do you guys remember? Remember when we added, we went 4, 8, 12, and then we also had 3, we had 6, we had 9, and 12. Their opposites would be 12. So I do want a 12u and a 12u, but I need one of them to be negative. So we can pick. Would you guys rather the top be negative or the bottom? Top? Okay. Then I'm thinking, what would I have to multiply the top equation? So this one here would say negative 4u. It would have to be a negative 3. Then I can fill in the rest. So negative 3 times 3c is negative 9c. Negative 3 times 33 is negative 99. This one I want to be a positive 12u, so this one will be a positive 4. And then what are my other two spaces going to be? Arlette, 4 times 6c would be what? What's 4 times 6? 24, yeah. We have to pull out the flashcards. I've got them if I need to. And do the thing where Arlette will stand behind Gloria, and then whoever gets. Did you guys ever do that?
like around the world.
Yeah, kind of like around the world. You never did that? No. It's good if you like have quick, like you're good at like. Sometimes you have to just think for a second. Doesn't mean you don't know it, but that's the only downfall for that. Okay, this one's the slightly tougher one. 4 times 36, which is 144, if I'm thinking about that correctly in my head. That one you might want to use a calculator for, and that one's more understandable. On a test, if it's a little bit bigger number, even though I feel pretty good that it's 144, I would probably just check with my calculator because I'd rather get as many points right as I can. Now, I'm doing my like giant equation addition problem. What's negative 9c plus, and I know it's plus because that's doesn't have a negative in it, so it's positive. Negative 9c plus 24c. 15c, awesome. These are gone, right? We should at least cancel out one of the variables because that's the whole point of picking these numbers over here, okay? 15c, what about negative 9 and positive 144? 45, good. All right, now it's kind of like smooth sailing from here. Divide by 15, divide by 15, c is equal to 3. And then I'm not going to do the next two steps because we kind of already did it over here, but I would take c equals 3, pick one of the equations and plug in 3, and then solve for u, and then maybe write it as an only pair. It depends. Okay? You guys feel okay about these solving the equations? If you hadn't been doing them on your homework because you were stuck, hopefully this will help you get going. Okay? If not, still come in and get extra help. All right, let's look back at the actual test. Let's talk about graphing these two things. Do you guys know how to graph? And this one here says y is less than 3. Do you guys know how to do it when there's only one variable? If it's only one variable, which is y, I'm only going to be touching the y-axis or the x-axis. Okay, this one I think kind of makes sense. If it only says y, it's only going to touch the y-axis. Okay, well it might touch the x-axis, but that's the one that I'm looking for. Right here, I'm going to leave it open. Would this be an open circle or a closed circle?
Open.
An open, correct. Okay. Now I need to make either a dashed or a solid line, so I can always make it dashed and fill it in solid. But just like this was an open circle, I want to use a dashed line instead of a solid line. Laura, can you put your phone on the table in front? Okay. And then I have to determine, do I shade above this line or do I shade below?
Above.
Okay, let's think about it.
Below.
Below or above? So this is the way I will usually like kind of make the analogy. Is anybody a really good singer? Anybody a good singer? No one really good singer? Who's someone? Oh, okay, Daniel. This example might not apply to Daniel, but who's someone that you would argue is a good singer in real life? That we all know. Oh. You guys can't think of someone that's famous for being a good singer?
Really?
No? You don't know anybody? Do you not watch
That
TV?
isn't my dad.
Huh?
That I know.
Everyone's not alive no longer? Is that?
Pretty much.
Oh, turn it in the back. The one under the red post. You don't need your phone, guys. Gloria. You guys can't think of one person that's a good singer? You guys don't listen to music? Or everybody you listen to, they're no longer alive? Who's your favorite singer, Arlette? Or one singer that you like? Taylor Swift? Okay. Huh? Do you guys? But okay, so let's pick. Okay, so let's pick someone like. A lot of times I'll hear like someone like Beyonce. Okay. How about someone like? When I did it last semester, someone said Ariana Grande. Would you guys argue that she's a good singer? You must be really good, or you just have tough standards. Okay, so there's no one that we can argue that is a really good singer.
Everyone sucks.
Everyone has disapproval. Okay, I'm gonna go with my first example. The first suggestion that I heard, and I'll go with Taylor Swift. She must be doing something right because she has a lot more money than any of us. Okay, I think she's like one of the top earners. Period. Yeah, I don't know that she's the best singer, but
I haven't like heard anything about her in like 2 years.
she just had a new song come out, right? Yeah, like a few weeks ago. I think it's called Me.
Me.
Brianna, do you know? Since you're the one that threw her out.
I've heard some of her songs.
Oh, you've heard some.
Yeah, I know it's Daniel's favorite.
Oh, okay. Daniel, put the phone away.
It is a favorite.
Okay. All right. So let's say hypothetically there's somebody named Taylor Swift and she was like the best singer. Okay. This Y would be you. Okay. Or I guess maybe we could talk about Mike. So you guys all agree that she probably has more money than anybody here. Probably more money than everybody in the entire school combined. Taylor Swift. Yeah. All right. Now, if this line is the like money line for Taylor Swift, would you say if you were less than this 3, which we'll say is Taylor Swift, would you guys be above her on the money, or would you guys be below her? You guys would be below her. So you would shade everything below. I've never had so much indecision between like debating who is a good singer or not. Okay. But in this case, why you are less than Taylor Swift. You have less money than Taylor Swift. So your money or whatever you have would be beneath her. Okay? And I guess it's a good example that it's a dash line because nobody has as much money as her anyways either. Right? I think she makes like hundreds of millions of dollars.
Says she's worth $320 million.
Yeah. So she's
That's
doing
it.
320 million.
Pocket change.
It's like yeah. All right, so let's do something similar, but with an actual line. We graphed lines a few weeks ago when we had to find the y-intercept, the b, and the slope. So the first thing I want to do is kind of make my line. Okay, I would start here. What if this said y is equal to 3x minus 4? What's my y-intercept in that equation? What's my y-intercept?
4.
Close.
3x.
Further away. -4. Technically, 3 is closer than 4, but -4, right? Because there's a minus right here. So -4, I would be right here. I'm going to leave it an open circle. Do you guys think I would fill this in or make it open? You'd fill it in, and why would you say that this one's filled in but the other one wasn't?
Because it's more than or equal.
Yeah, the or equal to, when I see that line, that's solid. A solid circle. It's actually going to give me a solid line instead of a dashed line like we had in the last problem. Okay. Then my slope, my m, would be obviously 3. You guys are probably all thinking in your head right now, right? Because we did so well with the y-intercept. Obviously 3, which if I want to like think about that as rise over run, it's up 3 to the right or to the left. Well, it's to the left or to the right. It's always to the right. Okay. So I wish there was a song that was like set to the right a lot. I think it's to the left, which is not as good, which is a Beyonce song. I know she's still alive, so you might not know who she is, Justin. It is an older song, so maybe it almost fits the criteria. So from this point, I'm going to go up 1, 2, 3, and then to the right 1. Another filled in circle because I have that. Oops, I didn't mean to do that. Because I have that or equal to. All right, I'm just going to have to deal with those counting steps. All right. Since it's a or equal to, I'm going to make it a solid line. Oh my gosh. Oh, there we go. And then it's going to be like this. Okay. Kind of falls off. Kind of doesn't fit on the graph very well. All right, let's pick an example of. Do you guys all have younger siblings? I don't know. Let's try to make an example where maybe it's the opposite of being not as good as. Does everyone have younger siblings? No?
I got two.
Okay, you have two? Then we'll make Daniel our focus here. So when I put Y, I'm saying you, okay? Are you taller than both of them?
Mm-hmm.
Okay, so the 3x minus 4, and I have this. This is you, and this is one of your siblings. Give me one of them.
Brother.
Brother. Okay, that's weird. It's like kind of reminds me of that Bird Box movie, where she names her kids boy and girl.
Boy.
Have you seen that one? Okay, so.
Christian.
Okay, too late. I already wrote brother down. Okay. Let's think about in terms of height. If that line is where your brother's at, because this line is really 3x minus 4, right?
Yeah.
That's how we got that line. Are you gonna be taller than? Would you shade above it, or would you shade below it? You shade above. So you are better than, or you are bigger than, or you are taller than your brother, which is, this is your brother right here, this line. So we're gonna shade above this line. Okay, a lot of times students have trouble deciding, do I shade above or below? Think about like making the Y a U and thinking about, okay, if the line is this part on the right, am I above or am I below that? Okay. You're above it. Maybe you're thinking you're a better singer or you have more money than Taylor Swift. Okay. If you had more money than Taylor Swift, I don't know.
I'm at school.
The school's important, but I think you might be okay if you didn't keep going on and do something. But actually, a lot of the like wealthiest people keep going further and further in school. So, all right. So let's do another example. Would you guys rather do 9 or would you rather do 10? And what time are we? 9:25. Would you rather do 9 or would you rather do 10?
Yeah, they're like the same as always.
They look very similar. Yeah. So a few of the signs are flip-flopped.
10.
10. Okay. Let's zoom in on this. And then let me lock this so I don't, if I need to erase it. Lock. Let's make sure. Okay, cool. So let's do this one here. So you should have it on your paper in front of you. Let's do this one in purple. What's my y-intercept? Not x. -2. Okay, good. We redeemed ourselves a little bit there. All right, so let me plot that. -2, obviously I mean I go down my y-intercept or my y-axis line. Oh, and before I even fill it in, is that an open circle or a closed circle? Open. Yeah, it's open. Because there's no little line underneath, there's no or equal to part. Then I use my slope. I have a negative sign. If there's no other number in front, it's just a negative sign, then that means -1. Okay? Does negative mean I go up, down, left, or right? What does that imply? It means you go down, right? So I'm going to go down 1, over 1. I have my next point, and then I could kind of go backwards now because I kind of have an idea of how this line is going. Dashed or solid line? Dashed. All right. Do I shade above or below? Are you better than the line, or are you less than the line?
Less than line.
We need to review these signs, right? Greater than, or equal to. Less than, or equal to. So this one here reads, y is you are greater than. So I normally associate greater than with being above something. Okay, can you make that connection? So if I'm going to associate it with being better than, I'm going to shade above. And I will shade everything that's actually straight up from it. Okay? Now, if I kept going on this line, it would keep doing this. So let me just shade this whole thing. Actually, let me just do that and save some time. Okay, so you don't have to like full on shade it in super dark. You might do like little lines or do like a soft shade. Okay, but I've got another equation. Let me do this one in blue. Y is less than or equal to negative 5x plus 2. First, I determine what's my y-intercept. Gloria?
Oh, y-intercept?
Yes.
For which one?
For the blue one?
2.
Okay, good. Not negative 5x, so that's getting better. Daniel P. Oh, I don't need to write B again. Daniel P, what's my slope?
-1.
We're looking at this one here.
Oh.
Negative
-5.
5, good. So remember negative 5, same thing as negative 5 over 1. Negative, as we said for the last one that we just did, it does mean going down. Daniel, put the phone away. Okay. Let me put the point on there. Where was our intercept? Right here. This one is going to be solid instead. Does everybody understand why it will be a solid circle instead? Okay. I'm going down, and I'm going down 5. So down 1, 2, 3, 4, 5 over 1, and then I get a point right there. So it is kind of steep. All right. Do I shade below or above on this line? I'll let you think about it for a second. Let me switch it to the highlighter.
Below.
Below, right? You are less than or equal to this line. And right here, it's kind of tough to tell because the line is so steep. But if I take this line here and I go straight down, straight down, straight down, straight down, straight down, then I know it's actually kind of like, it looks like it's on the left side. Okay? So I can shade that. So I have everything over here. Okay? Now, I need to be super clear because when I'm looking for a system of equations, you're looking for the things that overlap each other. Now there's one section that got shaded by the pink and the blue. Do you guys see where that is going to be?
Yeah.
Hopefully we can see it's right in here. Okay, so I'm going to like really emphasize that this here is my solution. Okay, so sometimes you might only see this specific part shaded in. I don't know how much dark it's going to get. Okay, so this part right there is my actual answer. All right, we'll stop there, guys. How many problems are on this review? Up to 16. I'll have a video for the last 6 a little later. Okay. Yes.